We'll try 59. So 59 says gradients in 3 dimensions. So we have a function, they want me to compute the gradient and evaluate it at a certain point. All right. So f of x, y, z. Maybe part A is not hard. Maybe I could move quickly through some of this. That would be good. And maybe we could do more. So it says 1 plus the sine of x plus 2y minus z. And they say my point p of pi over 6, pi over 6, pi over 6, right? And then they give me a unit vector. So this is my point. My unit vector, I'll call it u. They didn't say that. But they say that the unit vector is 1 over square root of 2, comma 0, comma 1 over square root of 2. Do I believe that's a unit vector? Sure, because if I square this thing, I get a half plus 0 plus a half. That's 1. Square root of 1 is 1. So that's a unit vector. This is a particular point, which is probably convenient for trig. And I have the sine function. So part A says compute the gradient of f and evaluate it at p. All right. That's what's that?
The point.
Yeah. There's a negative pi over 6 somewhere? Oh yeah, mine had a mark through it. You're saying the z coordinate is negative pi over 6, right? And the x and y are pi over 6? Okay, so that will make a difference.
We have different unit vectors.
We do? Oh yeah, we do. Sorry about that. That's for a different problem. So the unit vector is 1/3, 2/3, 2/3, is that right? Let me try and make sure that's a unit vector. 1/9 plus 4/9 plus 4/9, 9/9. I agree. Unit vector. Okay. So part A says, compute the gradient and evaluate it at the point. Here we go. Grad f is equal to a vector where basically what I do is I do the partials of these things. Now it's funny because, you know, even just to do one little piece of this takes some work, right? This is what you did. So let me just do df dx just for starters. Okay, and that's going to be the x-coordinate of the gradient vector. So that's going to be, well, 0 plus the sine, derivative of sine is cosine, bless you, x plus 2y minus z, times, by the chain rule, the derivative of what's inside, which would be 1, right? Okay. And then the next piece, right here, that's going to be cosine of x plus 2y minus z times 2. And the last piece is going to be the same thing times negative 1, right? So I guess what I really get is I get that grad f is the vector. I guess it would be, let me kind of simplify it, make it 1, 2, negative 1 times the cosine of x plus 2y minus z. That's maybe another way to write the gradient. And now I can evaluate it at that point, pi over 6, pi over 6, negative pi over 6. So let's get rid of some of this stuff. And let's finish part A by saying that grad f evaluated at point P is equal to 1, 2, negative 1 times the cosine of what? Let's see. Pi over 6 plus 2 pi over 6 is 3 pi over 6. Minus minus makes another plus, so plus the cosine of 4 pi over 6. So I have to think, what's the cosine of 2 pi over 3? I'm getting negative 1/2, right? So that's a negative 1/2 right there. And if that's negative 1/2, then maybe another way to write this is that the gradient evaluated at a point ends up being the vector negative 1/2, negative 1, positive 1/2. Okay? So that's the gradient. So that's part A. Part B. Find the unit vector in the direction of maximum increase of f at P. So this is now understanding what the gradient tells me, right? We want the direction of maximum increase or decrease. And we know that that's the right direction. Okay, there was the theorem. Oh, but what's the issue? So part B says, basically, take that thing and make it into what? A unit vector. So I guess what I need to do is divide answer to A by its length. Is that enough to say about part B for you guys? Is that doing the whole thing? Or should I do it? Is that okay? Part C? Part C is what people asked about the most. Find the rate of change of the function in the direction of the maximum increase at P. Okay, so, all right. So basically what I want to do now is, part C says to compute du in this direction. Okay, now I see something here. Remember I said I'm going to call this u? Let me not do that. They didn't do it. U is going to be my answer to part B. That's what I'm going to do. And I think that will then work. So, I guess maybe I'll sum up and then I'll go spend the last 10 minutes on the most recent section. To sum up, they have you compute the gradient, evaluate it at a point, P. You have this thing. Part B says change it to a unit vector by dividing by its length. But its length will be the answer to part C, because that's like your maximum possible rate of increase. And then part D says compute the directional derivative with respect to that vector. And what you should see is that part D is not as big as part C, because part C is the maximum change possible. That's kind of the point of the exercise. Okay? So I didn't work them out. We could.